Problem number 3, Midterm 2, 2006. This problem asks that for the function f of x equals x minus ln x, we find all local and global maxima and minima on the interval 0.1, 2. The best way to approach this problem is to first find all of the pertinent information, including the first and second derivatives, any critical points, and then solving for y for both the critical points and the endpoints of the interval. Let's start. By using the power rule and an exponential rule, we discover that the first derivative of f of x is 1 minus 1 over x. We discover the second derivative is equal to 1 over x squared. Next, we search for the critical points. We do this by setting the first derivative to 0 and solving for x. So, 1 minus 1 over x equals 0. And the answer is that x equals 1. There's only one solution for x, which means there is a single critical point at 1. Next, we find the y values of the endpoints and the critical points by plugging their value into the original function. We discover that f of 1 equals 1 minus ln 1, hence f of 1 equals 1. Now we do the same for the endpoints. We discover that f of 0.1 equals approximately 2.4, and f of 2 equals approximately 1.3. Next, we can use the second derivative test on the critical point to discover if it's a minima or a maxima. The result is a positive 1. Because it's positive, we know now that the critical point 1 is a minima. The next step is to begin to graph our function and draw our interval. Our interval stretches from point 1 to 2. Our endpoints are labeled as 0.1, 2.4, and 2, 1.3. Our critical point, which we know is a minima, is labeled 1.1. We can determine the concavity of the graph and whether it's increasing or decreasing on each of its intervals by testing a set of points. Here we use 0.5 from the first interval and 1.5 from the second interval. We now have everything we need to solve the problem. At endpoint 0.1, 2.4, we have a global and a local maxima. At critical point 1, 1, we have a global and a local minima. And at endpoint 2, 1.3, we have a local maxima.